Good morning, this is your Stat Sensei, Mr. Spensei, and this is Death Packet on chi-squared and regression. This will be problems 90 to 100, and this will be focusing on the chi-squared. So which of the following chi-squared distributions has the smallest number of degrees of freedom? Well, please remember, the chi-squared is a skewed distribution. It's skewed to the right. However, as the degrees of freedom increases, it becomes normal or becomes mound shape. And this would be degrees of freedom right here of 90 or greater. All right. So if we have 90 or more, we're going to be mound shape. And we will gradually move from being skewed to the right. Well, this can't be because this is skewed to the wrong direction. This one is mound shape. So this one has a lot of degrees of freedom. So when we look at these three, which one of them is the most skewed? All right. And I have to say it's kind of difficult to tell between um, B and E, but I can definitely see that C has the most at 0. It is definitely the most skewed. So C appears to be the most skewed. All right. So C appears to be the most skewed. That's my answer for number 90. All right. Number 91. Which of the following is a chi-square Gunner's fit test most appropriate? Estimating the difference between two population means. No, that would be a two sample T. Estimating a difference between, and by the way, this would be a two sample T interval because we're estimating. Estimating a difference between two population proportions. This would be a two proportion interval. So this would be a two prop interval. Finding the expected value of a probability distribution. That's an expected value. That is just a probability problem. Determining whether a categorical variable has a significantly different distribution of proportions than the expected distribution. That right there could be either a goodness of fit, or it's possible that it is a chi-squared homogeneity. So this is looking pretty good here. Determining the best shape for a set of data. Nope, that's not it. D is the only one that's a chi-squared. All right. 92. Which of the following describes a scenario in which a chi-square goodness of fit test would be an appropriate procedure to justify the claim? All right. So a statistician would like to show that one geographical location has a higher proportion of dogs that shed than another geographical. Well, in this case, we're comparing, and we have two independent random samples. All right. So this is going to be a two proportion Z test. So that's not going to be it. Our principal would like to investigate whether more than 50% of the students in a local high school eat in the school cafeteria. The principal has a random sample, so we have one sample. So this is a one proportion Z test, one sample proportion Z test. That's not it. A campaign manager would like to show that the distribution of individuals within several social economic categories. Okay, we have multiple categories is different than what the newspaper reported. So we're comparing one group of categories to another group of categories, and we have a one random sample. We have one sample, and we have multiple categories. This is our chi-squared goodness of fit. All right. Um, let's look at D though. A manager of water treatment plant would like to investigate whether there's a relationship between the amount of chemical used and the number of bacteria. If we're looking for a relationship, um, this is like saying we have an XY, so this is most likely going to be a regression. City officials would like to estimate the average price of gas in their city. All right, this is going to be, and they take a random sample. We're estimating, so this tells me this is an interval, and we're talking about a mean. So this is going to be a one sample's T interval. All right, one sample T interval. Number 93. A recent article published in Berry Weekly recorded a probability distribution for the different types of jelly that individuals prefer. Editors from a competitive magazine, Jammin', oh, Berry Weekly and Jammin', how cute, conducted their own study to test the distribution. The editors from Jammin' surveyed a random sample of 50 individuals and recorded the observed counts. All right. So we have observed counts here, and we got our expected counts here. And they said they have a random sample of 50. So if I add these up, this should total to 50. Um, they decided to test Berry Weekly's claim using a chi-square given as a fit, using Jammin's observed data compared with the number of expected based on Berry's weekly data. Which of the following is the correct null hypothesis? All right. So um, the null hypothesis is going to be equal. So that gets rid of the at least one of the proportions is different. That would be the alternative. All right. Now, what we didn't do is they did not give us the actual proportions. So if I take this information that they gave me and go to stat edit, I got a bunch of stuff in here. Got to clean that out. And I go to stat edit, and um, the expected counts, this is what we're expecting. So we're going to go ahead and put those in 16.5, 11, 9.5, 7.5, and 5.5. And I take those, I'm going to go all the way up, and I'm going to divide every single one of those by my total because my total is 50. So blue 2, or excuse me, let's go up. Try one more time. Go to the top of blue 2 and go blue 1 divided by 50. So all I did is take the 16.5 and divide it by 50, and I get 33, 22, 19, 15, and 11. And the one that has 33, 22, 19, 15, and 11, that is B. All right. So the answer choice for 93 is B. Oh, notice that we basically did this with the expected. We just divided all of these by 50. Okay. All right. Number 94. The table displays the distribution of percentages of different types of home heating sources for a large mountain city as reported by the newspaper. Okay. A chi-square given a fit test will be performed using a simple random sample of 100 homes to investigate whether the proportion of homes heated with each source is the same as what is reported by the newspaper. Which of the following represents the alternative hypothesis? Okay, the null is that wood stove equals 38% and electric equals 26% and propane equals 20% and radiant equals 16%. The alternative is at least one of the heating sources is different. All right. So we have at least one of the heating sources is the same. Nope, that can't be that one. At least one of the heating sources is different. Oh, there we go. Bing, bing, bing. Our answer choice is D. Number 95, which of the following is an appropriate description of the chi-square distribution? A chi-square distribution will contain positive values and will be skewed to the right, with the skew becoming more pronounced with increasing degrees of freedom. No, everything was good up until this part. When the degrees of freedom increase, it becomes normal. So everything was good until we got to that. All right, because it is positive, it is skewed to the right. All right, a chi-square distribution will only contain positive values and will be skewed to the right, with the skew becoming less pronounced with increasing degrees of freedom. That is true. We are going to become less pronounced with increasing degrees of freedom because we start becoming normal. Remember, we start off like this. We start off at 0 and we're skewed this way. but we become normal as we increase our degrees of freedom. Number 96, a job candidate at a large job fair can be classified as unacceptable, provisional, or acceptable based on past experience. A high quality candidate is expected to get 80% acceptable ratings, 15% provisional, and 5% unacceptable. A high quality candidate was evaluated by 100 companies and received 60 acceptable, 25 provisional, and 15 unacceptable ratings. A chi-square goodness of fit um, was tested to investigate whether the evaluation of the candidate is consistent with past experience. All right, so L1 is where you're going to put your observed values in, and then L2 is going to be your expected. So let's go ahead and do this real quickly. In L1, what are my I observed? I observed 60, 25, and 15. Well, remember my formula is observed minus expected squared over the expected. So my observed numbers need to be 60, 25, and 15. So 60, 25, and 15, that's an observed. 60, 25, and 15, observed. Oops, that's in my expected. That's wrong. That's in my expected. That's wrong. So it can only be these three because there's my observed value of 15, my observed value of 25, my observed. So it can be any one of those. Now we need to look at, well, how many degrees of freedom were there? Well, we have 1, 2, 3 categories. So our categories are 3 minus 1, which is 2. So that gives us 2 degrees of freedom. So that tells me right away that 96 is A, but let's work on the expected part because I want to help with that as well. So on the expected part, and normally I'd put my expected values, I put my observed in L1, my expected in L2. So we're expecting 80%, we're expecting 15%, and we're expecting 5%. All right, I'm going to take that L2 and multiply by 100. And that gives me 80, 15, and 50. I obviously mistyped a number. Stat edit. This is 0.8, 0.15, 0.05. There we go. Second 2 times 100. And you can sit there and go, oh, 80, 15, and 5. And that's where those expected values of 80, 15, and 5 came from. All right, number 97. Jana, a high school principal, hosted a movie event at her school. Jana's assistant kept track of the number of students in each grade level who attended the event. The distribution shown in the table represents the number of students each grade that were present. Jana knows that the grade levels are equally distributed across a school of 1,200 students. She would like to use a chi-square test to see what proportion of individuals in each class at the movie are also equally distributed. How many students would you expect at the event? First off, let's find out the total because they didn't give us the total. Let's add them up. So without doing anything fancy, I'm just going to go 52 plus 56 plus 60 plus 70. That equals 238. So we have a total of 238. Well, they said that they're equally distributed. Well, I have 4 groups. So that's going to be, all right, 100% divided by 4. Oh, I expect 25% in each group. So let's go to stat edit. And in L1, we're going to put the observed values, which were 52, 56, 60, and 70. In L2, we're going to put the expected percentages, which are 0.25, 0.25, 0.25, and 0.25. All right. Well, I need to take that and multiply it by 238. So second 2 times 238. Well, that means I'm going to expect 59.5, 59.5, 59.5. So I'm going to expect 59.5 for each group. So these are my expected values. Now it wants to know seniors. Well, we're expecting how many? 59.5, because we expect 59.5 for each group. All right. And if I add up 59.5 four times, I'm going to get to 238. Which of the following best describes the shape of the chi-square distribution when the degrees of freedom are less than 10? All right. Remember, if it's 90 or more, it's reasonably normal. If it's less than that, it's skewed. All right. So we're basically skewed to the right. And by the way, we always look at skewed to the right because we're starting at zero. Okay, zero and going to positive infinity. And this is for degrees of freedom equal to 90. This is degrees of freedom less than 90. Obviously, it gets closer and closer to that as we get there, get close to 90. It becomes more normal, but as long as it's less than 90, it's skewed. When it's less than 10, it's really skewed. All right, number 99. A Labrador Retriever Club has 130 members, 65 Black Labs, 44 Golden Labs, and 21 Chocolate Labs. Pablo is going to perform a chi-square against the fit test to see if the distribution of Labrador Retrievers in the club is the same as the national. Pablo is going to test his sample against the following null hypothesis, which gives these results. All right. So how many would they expect to see? Well, basically, they didn't ask for all this information, but I'm going to go ahead and approach it like I was running the whole test. The whole test is, oh, what are my observed values? I have 65 Black Labs, 44, oops, 65 Black Labs, 44 Golden, and 21 Chocolate Labs. What are the percentages for the national? Well, the percentages for the national are 53%, 39%, and 0.08%. Because we always want the observed in L1, the expected in L2. I'm going to go to the top of L2, second 2, and multiply it by my sample size, which is 100. That's my observed size. Oops. Blue 2 times 130. There we go. So I would expect 68.9 Black Labs, 50.7 Golden, and 10.4 Chocolate. All right. So the answer choice to number 99 is A. All right, moving on to 100. A bag of candy contains 5 different types of colored candies: red, green, blue, yellow, and orange. All right. So we have 5 categories. According to the manufacturer, bags should contain an equal number of each color. Students in a statistics class decide to use a chi-square procedure to test the manufacturer's claim. They opened a bag of candy and recorded the number of candies of each. The results are shown in the follow table. Which color contributed most um, to the chi-squared? Well, first off, I can actually run this test and find the answer, or I can look at it and go, well, and figure it out. First off, let's add up the number of colors because we need to get a total. And I'm going to go ahead and run the entire test, and we'll talk about other things as we go along. So 17 plus 24 plus 20 plus 25 plus 14. We end up with a total of 100. All right. I wasn't sure how many there were. And they said, hey, which color contributes the most? Well, if I have 5 of them, well, 100 divided by 5 means I should have 20% for each one of these. Well, the one that contributes the most is the one that's farthest away. This is 6 away. This is 5 away. This is 0 away. This is 4 away. This is 3 away. So orange is going to have the greatest contribution. But I also want to show that to you on the calculator, how you can know from the calculator. So we observed 17. Oops. We observed 17. We observed 24. We observed 20, 25, and 14. Notice what we observed. All right. And we're expecting 20% for each. And we can always take a percentage, blue 2 times the number of candies, which in this case was 100. All right. And if I go stat test and I run a chi-squared goodness of fit, so chi-squared GOF, L1, L2, degrees of freedom, we have 1, 2, 3, 4, 5 categories, so 5 minus 1. And I get these contributions. Well, this contribution was 0.41 or 0.45, excuse me, 0.45. The next contribution is 0.8. Then we have a contribution of 0, in other words, and then we have a contribution of 1.25 and a contribution of 1.8. Well, and that's where it says CNTRB. That's not contraband, that's contribution. Well, obviously, this is the largest value, so it had the largest contribution. Well, that was the orange one. Okay, now if I add up those values, watch what happens. 0.45 plus 0.8 plus 0 plus 1.25 plus 1.8 gives me 4.3. And you're like, well, what's that? That's my chi-squared value. My chi-squared is 4.3. And if I go back and run that test real quickly, there it is. There's my chi-squared value of 4.3. So the sum of the contributions equals your chi-squared value. All right. This concludes this video. Hope it helped. Look forward to seeing you on the next one. Thank you.